Space is vast, it's filled with wonders, and it's home to some of the most extreme environments imaginable. We've discovered planets covered in ice, we've found gas giants with storms twice the size of Earth. But today we're going even further. We're venturing into the heart of scorching Inferno Planets.
Welcome, explorers, to Tekkentrek. We're your guides to the past, powered by the future. Today, we're setting our coordinates for Inferno Planets. Get ready for a wild ride. We're about to explore planets so hot they defy imagination. We'll delve into the science behind these extreme environments. How do these planets form? What makes their atmospheres so scorching? And what are the chances of anything surviving on such a hostile world? Fasten your seatbelts, fellow trekkers. We're about to embark on a journey to the most extreme corners of the universe. Get ready to witness the awe-inspiring power of Inferno Planets, where glass rain falls and iron volcanoes erupt.
In the vast expanse of the cosmos, where celestial wonders never cease to amaze, there exists a class of planets so incredibly hot that they challenge our very notion of habitability. These are the Inferno Planets, worlds consumed by scorching temperatures and bathed in the searing light of their parent stars. Inferno planets are characterized by their extreme surface temperatures, often exceeding thousands of degrees Celsius. These planets are locked in a deadly embrace with their stars, tidally bound and subjected to relentless stellar radiation. Their atmospheres, if they exist at all, are a toxic brew of superheated gases and vaporized metals. But what exactly defines an inferno planet? How do these celestial infernos form? And what makes them so incredibly hostile to life as we know it? Let's embark on a journey to unravel the mysteries of these enigmatic worlds and explore the fascinating science behind their fiery nature.
The story of an inferno planet often begins with the life cycle of its parent star. Stars, like our own sun, go through various stages of evolution. As they age, they expand and become more luminous, altering the habitable zones around them. Planets that were once comfortably situated within their star's habitable zone can find themselves pushed closer as the star evolves. This process can be gradual, taking millions or even billions of years, or it can be relatively rapid, depending on the mass and evolutionary stage of the star. As a planet is drawn closer to its star by gravitational forces, it experiences an increase in stellar radiation. This intense heat can have a profound impact on the planet's atmosphere, surface, and overall evolution. The planet's surface temperature begins to soar, and its atmosphere can be stripped away by the star's powerful solar wind. Over time, this process can transform a once temperate world into a scorching inferno.
One of the most intriguing aspects of many inferno planets is their tendency to be tidally locked to their parent stars. Tidal locking occurs when a celestial body's rotation period becomes synchronized with its orbital period, resulting in one side of the body permanently facing the object it orbits. This phenomenon is similar to how our moon always shows the same face to Earth. In the case of inferno planets, tidal locking means that one hemisphere is perpetually bombarded with intense stellar radiation, while the other hemisphere remains shrouded in perpetual darkness. This extreme temperature difference between the day and night sides can lead to fascinating and dramatic atmospheric effects. The hot, illuminated side of a tidally locked inferno planet can experience temperatures hot enough to vaporize rock. This vaporized rock can then be carried by atmospheric winds to the cooler, dark side, where it condenses and falls as a rain of molten minerals. Imagine a world where glass or iron rain from the sky, a testament to the extreme conditions found on these alien worlds.
The atmospheres of inferno planets, if they manage to hold on to one at all, are a far cry from the life-sustaining atmosphere we enjoy on Earth. These atmospheres are often incredibly thin and composed of a toxic mixture of gases and vaporized elements. The intense heat from the nearby star can strip away lighter elements like hydrogen and helium, leaving behind a denser atmosphere dominated by heavier elements. Sodium, potassium, and even heavier elements like iron and silicon can exist in gaseous form in the scorching upper atmospheres of Inferno Planet. These elements can create a hazy, opaque atmosphere that scatters and absorbs starlight, further contributing to the planet's extreme surface temperatures. The composition of an Inferno planet's atmosphere can provide valuable clues about its formation history and the types of materials that make up its interior. by studying the light that passes through these atmospheres. Astronomers can identify the presence of specific elements and molecules, piecing together the chemical makeup of these distant worlds.
Inferno planets are realms of extremes where rain falls as molten glass and volcanoes erupt with fiery liquid iron. These phenomena showcase the incredible power of nature and the diversity of planetary environments. Glass rain and iron volcanoes evoke a hellish landscape, a world of fire and fury. Beneath these worlds lies a story of chemistry, physics, and cosmic forces.
Imagine a world where the sky rains molten glass, a relentless deluge of scorching droplets falling from a superheated sky. This is the reality on some Inferno planets, where temperatures vaporize rock, condensing into a deadly rain of glass, heated to thousands of degrees Celsius, reshaping the landscape with intense heat.
The formation of glass rain on Inferno planets is a testament to the power of extreme temperatures to alter the very nature of matter. Silicate minerals, the building blocks of most rocks on Earth and other rocky planets, are typically solid at temperatures we experience. However, on Inferno planets, where surface temperatures can reach thousands of degrees Celsius, these minerals undergo a dramatic transformation. The intense heat, often emanating from the planet's host star, provides enough energy to break the chemical bonds holding silicate minerals together. This process, known as vaporization, transforms the solid rock into a gaseous state, allowing it to rise into the planet's atmosphere. As this silicate vapor rises into the upper atmosphere, it encounters cooler temperatures. This cooling causes the vaporized rock to condense, transitioning back into a liquid state. However, because the cooling occurs rapidly, the silicate molecules don't have time to arrange themselves into an ordered crystalline structure, which is characteristic of most rocks. Instead, they solidify into a disordered amorphous structure, forming glass.
If glass rain wasn't enough to convince you of the extreme nature of Inferno planets, then prepare yourself for iron volcanoes. These geological behemoths erupt not with molten rock as we see on Earth, but with rivers of liquid iron spewing forth from the planet's fiery depths. Iron volcanoes are a testament to the unique composition and internal dynamics of these scorching worlds. Unlike Earth, where the mantle is predominantly composed of silicate minerals, Inferno planets are thought to have mantles rich in iron and other heavy elements. This difference in composition is likely due to the planet's formation closer to their stars, where heavier elements are more abundant. The intense heat within these planets, generated by a combination of gravitational pressure and radioactive decay, melts the iron-rich mantle, creating vast reservoirs of molten metal beneath the surface. These molten reservoirs can then be forced upwards through cracks and fissures in the planet's crust, erupting as spectacular fountains of liquid iron.
The heart of the Inferno unveiling the volcanic processes. Volcanic processes on Inferno planets share similarities with Earth. Both involve molten material moving upward, but Inferno planets have extreme temperatures and unique compositions. They lack active plate tectonics. Volcanic activity is driven by tidal stresses or internal heat. Inferno planet volcanoes spew molten iron and heavy metals. These eruptions create a spectacular and deadly display.
A symphony of destruction and renewal, the impact of glass rain and iron volcanoes. The combined forces of glass rain and iron volcanoes create a symphony of destruction and renewal on Inferno planets. These phenomena, while seemingly catastrophic, play a crucial role in shaping the surface and atmosphere of these worlds. Glass rain, with its relentless bombardment of molten droplets, constantly reshapes the landscape. The intense heat melts and fuses surface materials, creating bizarre, otherworldly formations that bear little resemblance to any geological features found on Earth. Over time, these glass deposits can build up, forming vast plains of obsidian-like glass, a testament to the planet's fiery history. Iron volcanoes, on the other hand, inject vast amounts of heavy metals into the planet's atmosphere and onto its surface. These eruptions can significantly alter the atmospheric composition, potentially influencing its ability to retain heat and its overall climate. The solidified iron flows, once cooled, would create vast metallic landscapes, crisscrossed by rivers of iron and dotted with towering volcanic cones. Seeking answers in the Inferno, studying extreme volcanism. Studying the extreme volcanism on Inferno planets provides valuable insights into the internal dynamics and evolution of these exotic worlds. By analyzing the composition of erupted materials, scientists can glean clues about the planet's mantle composition, its internal temperature, and the processes that drive its volcanic activity. While direct observation of these volcanic events is currently beyond our technological capabilities, astronomers can study the light emitted and reflected by these planets to learn more about their atmospheres and surfaces. By analyzing the spectra of light, which acts like a fingerprint revealing the chemical elements present, scientists can identify the signatures of vaporized rock and metallic elements in the planet's atmosphere, providing evidence of glass rain and iron volcanoes. Furthermore, future missions equipped with more advanced telescopes and instruments could potentially provide more detailed observations of these volcanic events, allowing scientists to study the dynamics of eruptions, the composition of erupted materials, and the long-term effects on the planet's surface and atmosphere. Beyond the flames, implications for other worlds. The study of inferno planets with their glass rain and iron volcanoes extends far beyond simply understanding these extreme worlds. It provides valuable insights into the diversity of planetary formation, the evolution of planetary systems, and the potential for habitability in the universe. The extreme conditions found on inferno planets highlight the wide range of environments that can exist in the universe, challenging our assumptions about what constitutes a habitable world. While these planets are clearly inhospitable to life as we know it, their study can help us refine our understanding of the limits of life and the conditions necessary for its emergence. Moreover, the study of inferno planet volcanism provides insights into the internal workings of planets, which can be applied to other potentially more hospitable worlds. By understanding the processes that drive volcanic activity on these extreme planets, we can gain a deeper understanding of how planets evolve, how their atmospheres are shaped, and the role of volcanism in creating and potentially supporting life.
Life as we know it. The limits of tolerance. When we think of life, we often envision creatures that thrive in environments similar to our own, temperate climates, liquid water, and an atmosphere rich in oxygen. However, our planet is but a single data point in the vast tapestry of the cosmos. To truly understand the potential for life beyond Earth, we must expand our horizons and consider the incredible resilience and adaptability of life itself. Life, as we know it, is remarkably tenacious. It has managed to gain a foothold in some of the most extreme environments on our planet, from the frigid depths of the oceans to the scorching vents of volcanoes. These extremophiles, as they are known, have adapted to thrive in conditions that would be lethal to most other organisms. Extremophiles teach us that life is not limited to the narrow range of conditions we consider comfortable. They provide a glimpse into the potential for life to exist in environments far more extreme than we ever imagined, perhaps even on scorching inferno planets. Inferno planets. A challenge to habitability. Inferno planets, with their scorching temperatures, toxic atmospheres, and relentless bombardment of stellar radiation, present a formidable challenge to the existence of life as we know it. The very conditions that define these fiery worlds seem antithetical to the delicate balance of chemistry and energy that we associate with living organisms. The extreme heat alone would be enough to denature proteins, the building blocks of life, and disrupt the intricate biochemical reactions that sustain living cells. The lack of liquid water, a universal solvent essential for life as we know it, further diminishes the chances of finding familiar forms of life on these scorching worlds. Moreover, the intense radiation from their host stars would bombard the surface of inferno planets with harmful ultraviolet rays and charged particles, potentially sterilizing any exposed environments and preventing the formation of complex organic molecules. Section 3. Extremophiles on Earth. Lessons from the Edge. Despite the seemingly insurmountable challenges posed by inferno planets, we find hope in the existence of extremophiles right here on Earth. These remarkable organisms, found thriving in environments that mimic some of the extreme conditions found on inferno planets, provide tantalizing clues about the potential for life to exist in these seemingly inhospitable worlds. Take, for example, the thermophiles, organisms that flourish in extremely hot environments, such as volcanic hot springs and hydrothermal vents. Some thermophiles can survive and reproduce at temperatures exceeding the boiling point of water, demonstrating that life can adapt to extreme heat far beyond what we once thought possible. Similarly, radio-resistant organisms, or radiophiles, have evolved mechanisms to withstand high levels of radiation. These organisms, found in environments exposed to intense radiation, such as nuclear waste sites and the upper atmosphere, provide hope that life could potentially find a way to cope with the harsh radiation environment of Inferno planets. Extremophiles on Earth provide a framework for understanding how life might adapt to the scorching temperatures of Inferno planets. While the specific adaptations would likely differ, the underlying principles of resilience, resourcefulness, and evolutionary innovation would likely apply. One potential adaptation for life on Inferno planets could involve the evolution of heat-resistant proteins and enzymes. These molecules, crucial for essential life processes, would need to maintain their structure and function even at extremely high temperatures. Scientists have already discovered heat-resistant enzymes in extremophiles on Earth, suggesting that similar adaptations could evolve elsewhere. Another possibility is the incorporation of metallic compounds into biological structures. Some extremophiles on Earth utilize metals, such as iron and sulfur, in their biochemistry. On Inferno planets, with their abundance of heavy metals, life could potentially evolve to harness these elements for structural support, energy transfer, or even as a means of protection from radiation. Seeking refuge, underground oases, and transient havens. While the surface of Inferno planets may be a scorching hellscape, there could be refuges beneath the surface, where life might find a temporary haven from the extreme heat and radiation. These underground environments, shielded from the worst of the planet's harsh conditions, could potentially harbor pockets of liquid water and provide a more hospitable environment for life to evolve. On Earth, we find evidence of life thriving in deep subterranean environments, surviving on chemosynthesis, a process of obtaining energy from chemical reactions rather than sunlight. Similar ecosystems could exist on Inferno planets, fueled by geothermal energy or chemical reactions between rocks, water, and dissolved minerals. Furthermore, transient havens for life might exist in the form of temporary pools of liquid water, formed by volcanic eruptions or meteorite impacts. While these environments would be short-lived, they could provide opportunities for life to emerge and potentially adapt to the extreme conditions. Our search for life beyond Earth has often focused on finding environments similar to our own, with liquid water, a breathable atmosphere, and a source of energy like sunlight. However, Inferno planets challenge us to expand our definition of a life and consider alternative biochemistries that might exist in the universe. Instead of water, life on Inferno planets might utilize other solvents, such as liquid methane, ammonia, or even molten salts. These alternative solvents, while seemingly exotic, could potentially support a different kind of biochemistry, with different building blocks for life and different ways of storing and transferring energy. Furthermore, life on Inferno planets might not rely on photosynthesis, the process of using sunlight to convert carbon dioxide and water into energy. Instead, it could utilize chemosynthesis, deriving energy from chemical reactions between readily available elements, such as iron, sulfur, or even radioactive isotopes. Detecting life on Inferno planets presents a significant challenge, as traditional methods of searching for biosignatures, such as the presence of oxygen or methane in the atmosphere, may not be applicable in these extreme environments. However, scientists are developing new techniques and refining existing ones to search for subtle clues of life in the most unlikely places. One promising approach is to look for chemical imbalances in the planet's atmosphere that cannot be explained by geological processes alone. For example, the presence of certain gases, such as phosphine or ammonia, in unexpected ratios could indicate biological activity. Furthermore, analyzing the light reflected from an Inferno planet's surface or clouds could reveal the presence of pigments or other molecules associated with life. These biosignatures, while faint, could provide tantalizing evidence of life's presence in these otherwise seemingly barren worlds. The study of Inferno planets and the potential for life to exist in these extreme environments pushes the boundaries of our understanding and challenges us to expand our definition of what constitutes a habitable world. While the search for life beyond Earth often focuses on finding environments similar to our own, Inferno planets remind us that the universe is full of surprises, and life may find a way to thrive in the most unexpected places. By studying these extreme worlds, we gain a new appreciation for the resilience and adaptability of life itself. We learn that the possibilities for life in the universe are far more diverse and awe-inspiring than we could have ever imagined. And as we continue to explore the cosmos, we must remain open to the unexpected, for the universe is full of wonders waiting to be discovered.
The exploration of Inferno planets presents a monumental challenge, pushing the boundaries of our current technological capabilities. The extreme temperatures, hostile atmospheres, and intense radiation require us to reimagine spacecraft design, materials science, and even the very nature of exploration itself. Traditional spacecraft, designed for the relative comfort of interplanetary travel, would be woefully inadequate in the face of such extreme conditions. Their delicate instruments would melt, their electronics would fry, and their structures would buckle under the intense heat and pressure. To explore Inferno planets, we need to bridge the gap between imagination and reality, envisioning and developing technologies that can withstand the Inferno. This is where the spirit of Tekkentrek thrives, in the boundless realm of human ingenuity, where we dare to dream of solutions to seemingly insurmountable challenges. Let's embark on a journey into the future of exploration, where we'll explore hypothetical technologies that could one day allow us to unlock the secrets of these fiery worlds. The first hurdle in exploring an Inferno planet is protecting our spacecraft and potentially ourselves from the intense heat. Traditional heat shields, designed for brief re-entry through a planet's atmosphere, wouldn't suffice in the face of constant, scorching temperatures. We need to develop advanced materials and innovative shielding techniques that can withstand the Inferno's relentless embrace. One promising avenue is the development of super-reflective materials that can reflect a significant portion of the incoming solar radiation. These materials, potentially composed of highly reflective metals or engineered metamaterials, would act like a mirror, bouncing back the heat and preventing it from reaching the spacecraft's sensitive components. Another approach involves utilizing ablative materials that absorb heat by gradually vaporizing. These sacrificial layers would slowly erode away, carrying the heat with them and protecting the underlying spacecraft structure. This technique is already used in some heat shields, but it would need to be significantly enhanced for Inferno planet exploration, requiring materials with much higher heat capacities and ablation rates. Once we've addressed the challenge of heat protection, we need to develop vehicles capable of navigating the treacherous terrain of an Inferno planet. Traditional rovers, designed for the rocky plains of Mars or the icy moons of Jupiter, wouldn't last long on a world where the ground itself could be molten. Imagine instead a rover with legs made of heat-resistant alloys or ceramics, capable of stepping over or even through molten rock. These legs could be actuated by advanced hydraulics or artificial muscles, allowing for a nimble and stable gait across uneven and potentially unstable terrain. To withstand the extreme temperatures, the rover's electronics and internal systems would need to be housed within a heavily insulated and actively cooled core. Advanced radiators, perhaps utilizing liquid metals or supercritical fluids, could dissipate the heat into the surrounding environment, keeping the rover's vital organs cool and functional. Eyes in the fire. Observing and analyzing the Inferno. Exploring an Inferno planet isn't just about surviving, it's about understanding. We need to equip our spacecraft and rovers with instruments that can withstand the extreme conditions while gathering valuable data about the planet's atmosphere, surface composition, and potential for harboring life. Traditional cameras and spectrometers, relying on delicate optics and electronics, would be useless in the intense heat. Instead, we need to develop instruments that utilize alternative sensing technologies, such as heat-resistant sensors that can detect changes in infrared radiation, or even sound waves to create images and analyze the composition of the surrounding environment. To study the planet's atmosphere, we could deploy specialized probes designed to withstand the extreme temperatures and pressures. These probes could be equipped with mass spectrometers, gas chromatographs, and other instruments capable of analyzing the atmospheric composition, searching for biosignatures or other clues about the planet's history and evolution. Sampling the extremes, gathering clues from a hostile realm. To truly unravel the mysteries of Inferno planets, we need to bring samples back to Earth for in-depth analysis. This presents an even greater challenge than simply surviving the extreme conditions. It requires developing technologies capable of collecting, storing, and transporting materials from a truly alien environment. Traditional drilling techniques wouldn't suffice on a planet where the ground could be molten. Instead, we might develop specialized scoops or harpoons capable of collecting samples of molten or semi-molten rock. These samples would then need to be rapidly cooled and sealed within heat-resistant containers to preserve their composition and prevent contamination during transport. For atmospheric samples, we could deploy specialized balloons or drones capable of ascending into the planet's atmosphere and collecting gas samples at various altitudes. These samples would then need to be carefully contained and returned to Earth for analysis, providing valuable insights into the composition, dynamics, and evolution of the planet's atmosphere. The human element. The challenges of Inferno exploration. While robotic missions will undoubtedly play a crucial role in exploring Inferno planets, the question remains, will humans ever set foot on these scorching worlds? The challenges of sending human explorers to such extreme environments are immense, requiring not only technological advancements, but also a deep understanding of the physiological and psychological limits of human endurance. Astronauts would need advanced spacesuits that provide not only protection from the extreme heat, radiation, and toxic atmosphere, but also a comfortable and habitable environment for extended periods. These suits would need to incorporate advanced cooling systems, radiation shielding, and life support systems capable of recycling air, water, and waste. Beyond the technological challenges, there are significant psychological considerations. The isolation, confinement, and constant exposure to extreme conditions would push astronauts to their mental and emotional limits. Extensive training, psychological support, and perhaps even the use of artificial intelligence or virtual reality to create a more immersive and comforting environment could help mitigate these challenges.
Our understanding of Inferno planets has come a long way since their initial discovery. What was once considered a rare and exotic class of planets is now recognized as a potentially common outcome of planetary formation. As we continue to explore the cosmos, our search for Inferno planets is expanding, driven by the thirst for knowledge and the desire to unravel the mysteries of these fiery worlds. The ongoing search for exoplanets, planets orbiting other stars, is yielding a treasure trove of data, revealing a staggering diversity of planetary systems and pushing the limits of our understanding. With each new discovery, we refine our models of planetary formation and evolution, gaining a clearer picture of the processes that shape the cosmos. Among the thousands of exoplanets discovered so far, a significant fraction are classified as Inferno planets, highlighting their prevalence in the universe. The quest to understand Inferno planets is intrinsically linked to advancements in astronomical instrumentation. As we develop more powerful telescopes and more sophisticated instruments, our ability to observe and analyze these distant worlds increases, allowing us to peer deeper into their fiery atmospheres and uncover their hidden secrets. Ground-based telescopes are constantly pushing the boundaries of observation, utilizing adaptive optics to compensate for the blurring effects of Earth's atmosphere and achieve unprecedented resolution. These telescopes, equipped with spectrographs and other advanced instruments, are providing valuable data on the atmospheric composition, temperature profiles, and even the presence of clouds and hazes in the atmospheres of Inferno planets. Space-based telescopes, freed from the limitations of Earth's atmosphere, offer an even clearer view of the cosmos. The James Webb Space Telescope, with its unparalleled sensitivity and infrared capabilities, is poised to revolutionize our understanding of exoplanets, including Inferno planets. Its ability to analyze the composition of exoplanet atmospheres in unprecedented detail will provide invaluable insights into the chemistry and dynamics of these fiery worlds.
While observations from Earth and space-based telescopes provide a wealth of information, there's no substitute for sending dedicated missions to Inferno planets. Imagine a spacecraft specifically designed to withstand the Inferno's wrath, equipped with instruments capable of analyzing the planet's atmosphere, mapping its surface, and even collecting samples for return to Earth. Such a mission, while ambitious, is within the realm of possibility.
Inferno planets as laboratories, unlocking the secrets of planetary evolution. Inferno planets, despite their extreme nature, offer a unique opportunity to study the fundamental processes of planetary formation and evolution. These planets, often located in close proximity to their host stars, provide insights into the dynamics of planet-star interactions and the effects of intense stellar radiation on planetary atmospheres and surfaces. By studying the atmospheric composition, temperature profiles, and orbital characteristics of Inferno planets, astronomers can refine their models of planetary formation gaining a better understanding of how planets form and evolve under different conditions. These models can then be applied to other planetary systems, helping us to understand the diversity of planets in the universe and the factors that contribute to their habitability. Furthermore, Inferno planets can serve as natural laboratories for studying the effects of extreme temperatures, pressures, and radiation on matter. These planets, pushed to the limits of their physical endurance, can reveal the behavior of elements and molecules under conditions that are impossible to replicate in Earth-based laboratories.
Inferno planets and the search for life beyond Earth. Inferno planets are unlikely to harbor life, but their study impacts the search for life beyond Earth. Understanding habitability limits helps narrow down our search for habitable worlds. Inferno planets help define the habitable zone, where liquid water can exist. They remind us that life as we know it is just one possibility in the universe.
The Inferno's Allure, a testament to nature's power. From rain that falls as molten glass to volcanoes spewing rivers of iron, Inferno planets stand as a testament to nature's raw power and the universe's boundless creativity. These fiery worlds, once shrouded in mystery, are gradually revealing their secrets, challenging our assumptions about planetary formation, the limits of life, and the very nature of exploration. While the Inferno's embrace may seem inherently hostile to life as we know it, it also sparks our curiosity, igniting a desire to understand the forces that shape such extreme environments. The study of Inferno planets pushes the boundaries of our knowledge, reminding us that the universe is far more diverse and awe-inspiring than we could have ever imagined. As we continue to explore the cosmos, Inferno planets will undoubtedly hold our gaze, beckoning us to unravel their mysteries and expand our understanding of the universe's incredible diversity. These fiery worlds, far from being mere celestial oddities, offer valuable insights into the fundamental processes that govern our universe.
Keep exploring. The journey continues. Our journey through the Inferno has been one of both wonder and humility. But the journey doesn't end here. In many ways, it's just beginning. As we develop new technologies, we'll uncover new wonders and face new challenges. So keep exploring, fellow trekkers. The universe is out there, waiting to be discovered. Until next time, keep your minds open, your curiosity piqued, and your eyes on the stars. This is Tekkentrek, exploring the past, powered by the future. Don't forget to like, subscribe, and hit the bell icon for more adventures.